Calculate the osmotic pressure exerted by a 500 milliliter aqueous solution containing 4.6 grams of dissolved magnesium sulfate at 25 degrees Celsius. Okay, so we know that the equation for osmotic pressure is pi equals the Van Hoff factor times molarity times the gas constant and times temperature. We know that from the equation, temperature has to be in Kelvin. The gas constant is a constant. It's 0.0821. Molarity is the moles of solute over the liters of solution. So moles of solute over the liters of solution. And then I is the Van Hoff. Okay, oh, and then our givens are, let's see, 500 milliliters of the solution. So, solution. And then 4.6 grams of magnesium sulfate at 25 degrees Celsius. Okay, so we can do what's easy first. Let's see, we know the Van Hoff is pretty easy. So Van Hoff for magnesium sulfate, there's only two components. So the Van Hoff, or two components, one magnesium and one sulfate. So the Van Hoff is going to be 2. Sorry. Okay. And then, let's see, so temperature is given to us in 25 degrees Celsius, but to convert that to Kelvin, we just have to add 273. So 25 plus 273 is 298 degrees Kelvin. So the next thing we have to do is calculate the molarity. So we know that molarity, like I said, is moles of solute over liters of solution. So we need to get, this is a solution, and we need to convert this to liters, and then this is in grams, we need to convert this to moles. So 500 milliliters over 1 times, we know that there's 1,000 milliliters for every liter. And that is 0.5 liters. And then from the periodic table, we have to convert 4.6 grams to moles, and so we need to use the molar mass from the periodic table. So magnesium, or the molar mass for magnesium sulfate. So magnesium is 24.31, plus we only have one sulfur, which is 32, plus we have 4 oxygens at 16. So add those all up to get the molar mass of magnesium sulfate, and that's 120.37. So now to use that to convert, we have 4.6 grams, that's our given, over 1. We want the grams to cancel out, so put the molar mass on the bottom is per every 1 mole. And that is 0.038. And put these two in our molarity equation, and we have big M equals 0.038 over 0.5, and that is 0.076 big M. Okay, so we have our molarity, our temperature, our Van Hoff, and our gas constant. So plugging all of these different values back into the equation, we have 2 for the Van Hoff multiplied by, here, just so it's easier. So 2 Van Hoff multiplied by the molarity, which is 0.076, multiplied by the gas constant, 0.0821, multiplied by the temperature, which is 298 Kelvin. And when you multiply all those out, we get 3.7 atm for the osmotic pressure.